Okay, not quite done with inverse functions yet. We have to talk about the derivatives of our inverse trig functions. So the derivative of inverse of sine, the derivative of inverse cosine, and the derivative of the inverse of tangent. So we're going to get those three. We're actually going to figure out the derivative of the inverse of sine together, and then that will lead us to the other two inverse trig derivatives. So here we go. Y is the inverse sine of x. We've got to derive this. All right, where do we begin? Well, I know for a fact this is a pain in the butt, inverse sine. Don't really know what to do with that. So I want to get rid of that. How do you get rid of inverse of sine? Well, that's right. You take the sine of the inverse of sine. Because we know that two functions that are inverses will wipe each other out. Think e in natural log. E to the natural log of x is just x. Right. And the sine of the inverse of the sine of x will also just be x. But if we take the sine of the right side, what else do we have to do? Yeah, we got to take the sine of the left side. So we have the sine of y right there. So x is equal to the sine of y. All right, now that's something that I can work with. This is something I can derive. Because these two equations are the same thing. They're just one's using inverse notation, one's not. I don't know how to derive this, but I do know how to derive this. I can definitely derive the right side. Derive the left side, what rule do I need to use? I need to use the chain rule. It's going to be derived implicitly. It's the sine of ugly, but that's the chain rule. So here we go. Sine's derivative is, that's right, it's cosine. So we have cosine. We keep the ugly, and then we multiply by the derivative of the ugly part. And the derivative of y is dy dx. Yay, that's what we want. We want a dy dx. Over on the other side, derivative of x, exactly, 1. So what did we just do there? We took the derivative of both sides. We took the derivative of the sine of y, and we took the derivative of x. Okay, that leads us to dy dx, which means that we can now solve for dy dx. All right, so dy dx, how do we get cosine of y over to the other side? That's right, we're going to divide by it. So we have dy dx is 1 over the cosine of y. Well, that is our answer, but that's not a good answer because we want the derivative with respect to x. And this is most definitely not with respect to x. We've got to turn this back into x. So how are we going to do that? Well, we've got to do a little more trig identities here. The one that we used before, remember this one? Sine x squared plus cosine of x squared is equal to 1. Okay. Well, does it really matter what the independent variable is, whether it's x, y, or an m? No, it doesn't. So let's make this sine squared of y plus cosine squared of y is equal to 1. Okay, now if I can get something for cosine y, that's a good thing. So I got to get cosine y all by itself. Which means I got to get the sine squared over to the other side. That's not hard, that's just subtraction. So cosine squared y is 1 minus sine squared y. Okay, now I got to get rid of a square. How do you get rid of a square? That's right, you're going to square root. So we square root the left side, and we can square root the left side as long as we square root the right side. So what do we now have? We have the cosine of y is equal to the square root of 1 minus the sine of y being squared. Okay, let's put that in. So we have dy dx is equal to 1 over, by substitution, the square root of 1 minus sine squared y. Now, right now you're thinking, Sylvain, we still haven't figured out the problem because we still have a y right there. We want to get rid of the y. Well, actually, we don't want to get rid of the y. We want to get rid of the sine of y. If only there was an expression on the board that told us what the sine of y was equal to. Oh, wait, there is. The sine of y is x. So therefore, dy dx, by substitution, is 1 over the square root of 1 minus x squared. That is your derivative of inverse sine. So let's put that in. 1 over square root 1 minus x squared. Okay, now we can do this all over again with cosine. And if we do it all over again with cosine, it's going to be very similar. The only difference that ends up happening is that there's a negative symbol involved. So negative 1 over 1 minus x squared. That's the only difference between the derivative of inverse sine and the derivative of inverse cosine. These are the two harder ones to determine. The easier one is 1 over tangent. You can derive that as well. When we do so, we have 1 over 1 plus x squared, which is beautiful. Nice and easy, no square roots involved, just 1 over 1 plus x squared. There's your 3 inverse trig derivatives.